Hi, this is Ryan with Tilt 5, and today we're going to talk about the camera. So there's a lot of topics to go over, and first we're going to talk about the basic concepts and how Tilt 5 has a slightly different camera than you might be used to. Then we're going to talk about how to possess the camera and make sure that you're actually going to the right one. Then we'll be looking into adjusting movement based on head look, the settings for the spring arm, which is a really useful component. Then how to adjust the spring arm manually by connecting them to some button presses with the Tilt 5 wand. Then we're just going to move the camera up and down a bit. And then we're going to go into a completely different project from the third-person template we've been using and check out the Dune Buggy game sample, which has been set up with Tilt 5. And so we're going to go over some of that setup, and then we're going to show how we zoom in and out using some button presses that change world to meters. There will be a quicker or smoother zoom, and we're also going to finish with camera rotation lag, which is on the spring arm, and we're going to go over some different values, making the camera also not follow the pawn at all with rotation, and then ways to change these using button presses. So conceptually, the Tilt 5 camera is a lot like a VR camera. You can move your head around in space, and this will change both the physical location of your head and then the digital version of the camera that's attached to your head. So you can just move around, and that's normal. What's special about Tilt 5 is that we have a board, and the relationship between your head and the board is always going to be based off of where that physical distance is. So, you've got your head position, and it's measuring it to the origin of the board, and that is where we usually put game objects and characters. So if your head is here, and the center of the board is here, and your virtual camera is looking at a character who's at the center of the board, this is what you get. Now, obviously, if we were to keep the camera locked off, then you can move your character around the board, and they would get to the edges, or if they were to walk off, then you wouldn't be able to see them past the edges of the board. But if I were to move the game origin, let's say I move it up about the height of the character, since the camera attached to your head would stay in the same place, what you'll actually see is that the character will move down in relation to the origin, which is now above them. The same thing would happen if we moved it to the right. If we moved it this distance over here, the camera is being panned over there, but what we would see is that the character would move left the same amount. You can also zoom in and out. The approximate way that would work is looking like this, where now we can't actually scale the board in real life, but you can see that if we did this in the game, then making the board bigger would make the character smaller, and just like making the board smaller would make the character bigger. So we've got some of these interesting inverse relationships once we're messing with the camera in Tilt 5. Before we get into some of the fancier settings, I want to call out that you have to possess the camera that is being controlled by Tilt 5. And so the most important thing, if you're using a third-person pawn, for example, is to just go and type in possess into the controls and see if it's being auto-possessed. Then if it's auto-possess is on and it's set to player 0, then you're fine. This works great for the third-person character because it's done by default, but if you were to make your own custom blueprint that, for example, only had an AR camera parent and maybe a wand in it, then you need to make sure that when that goes into your scene, that it's getting possessed. So once you have made sure that your auto-possessed player is on, you will get what we showed before, which looks a little like this. And so we've got the character. When you move right, the character moves right. When you go left, and I have the wand itself visible. And so this is working just fine, and except if I were to turn my head and go onto the opposite side of the board, like this, when I press up, instead of walking away from me, the character walks, I guess, left based on where I am now. So this is because we're not adjusting for the movement based on your head position. And there's a quick little node that you can do that in Blueprints. So I'm going to go and show how that we would add that. So go to the third-person character, open up the blueprint, and inside the character movement, see we haven't even done much in this blueprint here, movement input. So by default, the movement input that goes into your forward vector and your right vector is multiplied by the world direction, and that world direction comes from the control rotation of the pawn. And it just gets the yaw here, it makes a rotator, and then it gets the vectors. We actually want to replace this with a quick little node that's called Get Orientation and Position. So if I delete this and type in Get Orientation and Position, this is a head-mounted display node. So Get Orientation and Position gives you your actual HMD rotation and your HMD position. In this case, we want the rotation. So I just split the struct pin and get the yaw. So replacing the old yaw with the new yaw. This will probably won't look like much, but if I play the game, now, regardless of which direction my head is aiming, if I press up on the controller, the character walks that way. And I'm sort of cheating this by showing that this is me just holding up, but turning my head to the right, turning my head to the left, the character steers a little bit. If this is the result that you want, then it's good, because if I was on the opposite side of the board, this character would not walk with inverted controls. They would actually be walking exactly the direction I want. So when we go into some of these camera settings for the spring arm, which is called a camera boom in this project. I've named it camera boom spring arm because the name of the component itself is spring arm, and I think there might have been a little confusion about which component this was. So this is how we set it up. We have an AR root, we've got a spring arm, and there's a lot of good stuff that happens with these spring arms. I kind of recommend using it as the parent to your camera. And so there's some settings that are very important, especially for this third-person project. And one of them is use pawn control rotation. This might be like the magic checkbox. If you don't have it checked, then the character will not move in the right direction, or the camera will actually start to follow it when it walks in certain directions, and then when you press backwards on the stick, it'll follow it, but it'll whip the camera 180 degrees and look really weird. So I just want to show inherit yaw. I've got it turned off. So now we're going to go and add the ability to rotate this. So all I'm going to do is I'm just going to go and look for the tilt 5 wand and get the right wand, and I'm going to check the 1 button. So now I have the tilt 5 1 button, and I'm going to drag our spring arm in, and then when we click this button, we're just going to add a local rotation to it. So I'm going to add local rotation, and we're going to add 90 degrees in Z, which is the yaw. And so that's going to happen every time that we press this button. So here's what this looks like. Now again, if I didn't have the inherit yaw unchecked, it would not rotate my character at all. All right, so here's the character walking around, and when I click the 90 degrees, boom, they have changed their orientation. We can do it again. I guess, oh, I'm in a wall. So the one problem that immediately emerges here is that if I rotate the whole world 90 degrees, now when I press up, my character's going to the left. So we rotated the parent, but we didn't tell anything else about that, the movement component. So in this case, we can change this by adding that offset to a variable and then using that variable with the character movement. So in this case, instead of just adding a 90 degrees here, I'm going to split this, and I already made a, this was the variable that kind of came out of it. So this is just a fixed variable that has the 90-degree rotation in it that we want. And then after we do this rotation, we just want to keep track of it. So this is just a float that's currently at 0 called current yaw. And we want to get our current yaw and add it to this and then save it. So we're just going to do add float. We add the 90 degrees to our current yaw, and then we set it. So set it to this, and that solves part of it, but this isn't being read anywhere. So the place that we put this in is down here. You can see I already had this set up. I take the device rotation Y yaw from the headset, and I just plug that into the current yaw add, and then that goes into yaw here. So before it was just taking the direction that your head was looking. Now it's taking the direction that your head is looking, plus any rotations that we put onto this spring arm. So here we have the version where you have adjusted the 90-degree rotation on a button press. And in this case, I'm pressing up, and it's always going away from me regardless of which way the camera has been rotated to. So this can be super useful, giving players the ability to snap 90 degrees. It can also allow you to have, if you have a multiplayer game, put people on different sides of the table and manage it that way. So that is useful. All right, what else we got? Inside the third-person character, there's a couple more settings on the camera swing arm, which are useful to be able to mess with. Notably, if you ever want the camera to be closer to the action, then all you have to do is grab the spring arm and move it down. Think of this camera right here as the origin of the board, the middle of the board itself. And so anything, when I move it down, the board itself can't move down because it's a physical object, so everything else has to just move up instead. And just moving that very quickly, the character is now, well, a lot closer. Let's see. You can see the wand can now go through the table rather than running into it. So this character is now kind of standing and projecting out of the table. Easier to see in AR. Probably moved it a little bit too much. But another way to mess with this without changing the actual root location of this, which could cause issues, is this target offset on the camera as well. You can just do a Z offset, which essentially does the same thing. So if I move it down, our Z offset will push us a little farther into the table, which basically pulls things out of the table. The inverse of this, of course, is if we push this way above the player. Whoa. Oh, 5,000, not 500. 500. So from this standpoint, the character is way, way sunk into the board, like almost to my floor. And this actually can be a desirable effect. You can embed all of your art into the table and get a 3D effect that way. It's a little bit hard. I have to lean in to sort of see them at the bottom, but this is something that you can control either in the actual setting itself or in blueprints. So if you wanted to change this using button presses or change it dynamically, all of these are exposed in blueprints, and you could just add this value or subtract from this value. So now I'm going to jump over into another project and show off a few of the different camera settings that we have over there. Here we've got a completely different project. This one came from the Samples tab of the Epic Store. And this is an old favorite called the Buggy game. And so if you go to your Epic Games and scroll down, you eventually get to a bunch of legacy samples. And right at the bottom is the vehicle game. This one was made many years ago and gives you a physics-based dune buggy and a really cool desert environment. And so I downloaded this, created a project with it, and now I've got Tilt 5 already set up, which means I've got the plugin running. I've wired up the input of the axes to going forward and turning. And it looks like world to meters. Looks like, oh, my world to meters is set to default in here because we are changing it dynamically in the project. So this is a good example of showing a different way to use the camera. In this case, we have taken the basic camera and turned it into a follow camera. And that includes using the camera lag in order to get some different results. So here inside the vehicle buggy, which is in vehicles, VH buggy, blueprint, VH buggy. That's the blueprint that we're in now. This camera started out with some additional target arm length and I think some other offsets. I've zeroed all of those out. There's no offset. There's no locational transform. That puts us locked into the buggy is right in the middle of the table. This is what it looks like in Tilt 5, at least from my point of view. I see the game board at table height, that's about the height of the desert. This is me dragging the controller on the top. I can poke the center of the game board, and that's where the vehicle is. And you can see that I've set up the wand as a motion controller, so I can zoom in, or I can do that. I've also wired up some buttons, so in this case, the X and the B button can zoom me in, and I can actually, I've got it clamped, but I could otherwise just zoom all the way in. And if I will do the opposite, I can zoom out. I can zoom way out. I can make this very, very small. So this is the first camera control I'm going to show, and let's pop into the blueprint. In this case, I just set the world to meter scale on start. So this is begin play. I just wired it from the begin play and fired this custom event. So this is set world to meter scale based on our default, which looks like it's 6,000. Then on tick, I'm also setting world to meter scale based on the value, but then of course we can mess with this value. And so we do that here using the Tilt 5 B button. We take the world to meters that it's currently at, we multiply it by 1.5 so it gets bigger, and then we set it, and then we clamp it, and then we set it to the world to meters, which then immediately updates it and changes the world to meters. So do the opposite on the other direction. Looks like this is the one that makes the world bigger by making the world to meters smaller. It's always inverted, so yeah. And clamp it out and set it. It looks like my clamps are actually different max. Whatever. So that's how I was just zooming in and out just now. The smoother way to do this is to use a lerp. In this case, using a timeline. So this is just a really basic zoom in timeline. It goes from 0 to 1 at with a curve. I go into the play from start, and then on update. It sets the world to meter default to the lerp value between its old value and this new clamped value after it's changed. So this does a smoother zoom in and zoom out that I prefer, but it's pretty easy to add a timeline in. So the fun of this game is obviously not just zooming in and out of camera, it's racing around a track. In the input manager, I wired both the up button on the wand and the trigger to both do the accelerate. So in this case, I can go forward to my max speed pretty quickly, and then hitting left and right on the wand turns my character. So the vehicle, I can steer. I might be zoomed in a little much, so it's a lot easier if you can see farther. And then of course you're going to run into the walls because I was going too fast. So in the vehicle buggy, we go to our camera spring arm, and then we take a look. Yep, did have it turned off. So we've got enable camera lag. This one is a lot simpler. I think we already covered this in the third person template. This one lets you have the character move off of the very center of the board, and then like a rubber band, and then whatever this max distance is. I think I actually want to try a lot larger one on here. But camera rotation lag is, I think, where the fun happens. So if you can take a look at these exact values here, camera lag speed, whatever, but camera rotation lag speed, I think it starts set to 10 by default. 7. Okay, it starts at 7 by default. That value is so high that you almost don't see the camera rotation lag. So I am going to default it down to 1, and then we're going to toggle a couple of different versions that we've got on some of these buttons in the game. So now that it's on, there is already, so this is the 1 value, there is a gentle rotational follow that feels pretty nice. It definitely, it lets you follow the track to a certain extent, so I think within about a second, I kind of catch up, but it's not as immediately juddery or responsive as when it's not on at all. So this is 1 value, but I have another value that I can do here, which, okay, so this is turning it from 1 to 3, and it's tighter. It's a lot closer to the original, but there's still, you can see that the vehicle turns a little bit before it changes, and then I can toggle it back, and this is my slightly slower version. And then I also made a button where you can turn the camera lag essentially off. So now I've just hit it. Now the camera is not following the rotation. It looks cool. It feels cool. It's really hard to see what's coming, so I'm probably going to crash soon. But this goes well in conjunction with zooming out a lot. So if I just kind of spam my zoom out button, I can go even farther. Yeah. So now I've got, this thing is, it's microscopic. It's the size of a bug. Oh, am I gonna make the jump? Can I make the jump? Nope, I was aimed wrong. But if you wanted like a racing game that was really just 1-to-1 scale, that's probably about how far you'd have to zoom out. And in this case, the camera lag speed is set to 0.01. So there's technically camera lag. It's just when the value is really, really low, the camera just doesn't really follow quickly enough for you to notice. Here's a quick look at the blueprints that I made in order to wire up those inputs for changing the camera rotation lag speed. Most of the time, you're probably going to want to just experiment with a few values and keep those for the majority of your game. But in this case, I wanted to show different versions in game. So I made a very simple flip-flop that just goes between one value and the other. This is the Tilt 5 Wand 2 button and the 1 button. This one, it takes the spring arm. Once you've dragged that component out, you can drag and find camera rotation lag speed here. So you can set this using that. And in this case, it defaults to 1. The first time I press it, it flips over to 3. This is the higher number, and then it flops back to the default. This is the one where I basically froze all the camera lag. And so this one starts at 1, goes to 0.01, and then goes back to 1. And this is pretty much it for the Dune Buggy example. The camera rotation lag is one of my favorite little things. Use these values or tinker with your own for faster and slower. Try it out in different projects and see if you like it. Once you have a panning, moving camera on the Tilt 5 board, it can bring a lot of I guess extra energy to the games and open up a whole lot of different projects which you might not have thought would work on a tabletop system if you imagine that things stay locked onto the table. Once you're playing with the camera, you can do just about anything.